So it's all up to you now.
Okay, let's start. I missed several lections of Alexei. So let's do um, our lesson in another way. First of all, I want to tell that Alexei told you a lot of theory, but of course we have, if we want to do something good at any exhibition, at any conference, we have to talk very good any in any ways. So, can you show me your home tasks and explain what is going on and explain what have you done? Okay, who want to be the first?
I can go first.
Okay,
Do you want me to share the screen? Or
yeah,
okay.
I can stop my video, for example. I think it will be better.
I think it
Or
doesn't interfere. So
yeah, share your screen, please.
okay, do you see?
Yeah, great.
So the task was cell wars, am I right? Where we have red and blue cells, or something else.
Okay, can you explain me what is going on?
So first of all, I changed the grid to be a dictionary, so we can call it by its name.
No. For example, if we are on conference, you have to talk something with the beginning. So let's go from the beginning to the end. From the beginning, what are you going to do? What are you going to say?
Well, I'm going to explain the code of the homework.
Great, great. Of course, to say the truth, when we worked with Alexei offline, sometimes we asked people, students from another grades, to came to our room and to create a lot of house. So it's okay when you're trying to explain something to people who is okay, who is knowing something about maybe who can know maybe something about math, something about Python, but nobody can be sure in it. So let's from the beginning. At first, you want to and start.
So we want to demonstrate how the so let's start from the beginning. We have plain black matrix. Can I say matrix?
Okay.
Or is that, or the kids won't understand?
Now to talk whatever you want. If we can discuss some mistakes at the end.
Okay.
I support this. I support this last comment from Andre. Just for you to understand, you will be presenting the results of your work to the teachers. I don't know, maybe some professors from university, to the jury, and that does not mean that they will understand everything. Actually, they might be quite low qualified, unpredictable. We don't know that. So indeed, explaining more thorough is preferable rather than explaining too little. And what I want to say that this really is a very important part of the participation of the important part of the oh my god, competition, because only after this presentation the jury will give marks and decide on the score and the place. in the competition. So
Okay, so you have
very
to
simple.
talk in a very, very simple way and explain such as everyone can understand you.
Okay. So we have a board, and on the board there are 5 types of cells. We have blue cells, we have red cells, we have red warrior cells, blue warrior cells, and normal cells. So blue and red are rivals, and
Can I
they
add a little? For example, if you have a text, if you can show the text on your screen, it's a good opinion. So it's a good option. So you can scroll up, and I think we can find type of cells.
we have it here.
Yeah, great. So when you talk something, it's a good way to show something.
Okay.
So, but I don't see anything about virus.
Yes, I can add.
Okay. Okay. Great.
And blue and red are rivals, and they compete for the space on the board. The way they behave is very simple. If 2 or 3 cells are nearby, they can stay. But if there is more or less, they will just die. And if if blue and red are next to each other, they will also die. And white cells are like unoccupied. And so
Great. I think if you change black and white, it can be more useful.
if I change black and white.
Yes.
Oh, okay.
So now, as I understood, can you scroll up for a little?
Okay.
Oh, no, not so much. Can you scroll down? Yeah, great. So you can find the longest string, and here you can use listed column map.
Yeah.
So black is nobody.
Yes.
Okay, yes. Now normal cells black, blue special blue, cayenne
Red special sign are blue warrior cells, and pink are red warrior cells.
Okay. Let's start. I think you can restart, and I think it can be more useful, more.
But it takes like 20 seconds to.
It's okay.
You
can explain a picture. Okay, it's disappeared. Great.
Okay. While it executes, I will say something about starting values. So
Great.
at the start, approximately half of the board is filled with normal cells, and there's no blue, red, or any warrior cells. The blue cells spawn on each tick, and they stay for duration k, and then they disappear. And same goes for red cells. As we see, we can see blue cells eating the black cells, which are normal cells, or the red one eating. And if we count the frames, we can see 10 frames it takes 10 frames for them to disappear. And that's about it from the animation.
Okay, can I ask you the first idea, which I couldn't understand, what means frame?
Frame is one picture. We create a video that it's a current state of the board. It's like if we have let me
So you can talk that frame is
it's like a
connected
time
to
for
great.
computers. It's like time for computers.
So one frame means
One time tick.
one. Okay, great. Now it's okay. Yes. So we can see how you can explain this picture. So you talk a lot about different wires, so we can see how the boy is going on. Am I right?
Okay. Yes. So we built about the half of the board with normal cells, and we started with some red cells and some blue cells, and
Stop,
each
stop, stop.
tick.
You are in. You are trying to get yourself into a cell. What I means? I means you are trying to talk with people who is know everything about this model. So first of all, you have to talk about the model. Now I see a lot of different points. Mm, small, very small points. Blue points, white points, black points. And now I understand that each point is something and frame is a time. So now you talk about cells. So what kind of cells? I mean, you have to explain at first that you are talking about live cells, or maybe it's cells for animals, or maybe it's cells of I don't know about of tree, or maybe something else. So first of all, if you want to tell your idea to somebody, you have to talk about what kind of cells are you using. So these cells, they can die, they can be alive, they can burn, they can do something else. So first of all,
we can interpret it as we want. They can represent animals, or we can interpret it as, let's say, biological cells.
right.
Okay.
No, to say the truth, not even cells, biological objects. Maybe it's more clear, it's more understandable.
And let's say a frame is time as integer.
Yeah, I know it's very very hard. The most unusable, the most hard, the most complex thing is to explain your idea in very simple words and to do it quite fast.
So that's pretty much it.
So let's begin from the. Let's start from the
Do we
beginning.
have any questions?
No, it's okay. It's okay.
Okay.
So it's a way how you can explain to somebody.
Sorry, just one short interference. Guys, you're a team, so if you understand how to help in some situation, you can intervene and, well, say something, do something, suggest something. It's very difficult to be alone. So please feel free to speak if you understand how to help.
Yes, it's a good idea.
I mean, there will be no situation where when you will be questioned, I don't know, one by one or something like that. I mean, you will always, all the time be together. You will solve the problem together, and you will defend it together. defend yourself.
Would you mind just repeating the task? I didn't hear it correctly.
Okay, the main idea of today's lesson is how you can explain your work in very, very simple words and in several sentences. So the first idea is that these points on this picture is biological objects. The second idea, the frame 1, 2, 3 means time. It's very easy, but you have to explain it. So we have two good ideas, and then we have to continue. So the third idea, what we have to talk about?
I'm sorry, would you mind repeating it again?
Okay.
I logged off. Wi-Fi here is awful. I just switched to another one. Hopefully it's going to work now.
I mean, you have to explain this picture. For example, you have to explain your model. So first of all, you have to explain that everything we see on this picture is biological objects. The second number of frame is time. And now it's time to explain the model. What means black points, what means white points, and so on.
So the black points represent normal cells.
Great.
They behave very similar to red warrior and blue warrior. They are born if 2 or 3 normal cells are around them. So, for example, in this example, one can be born here, but not here because 4 normal cells are near that spot. So in a real life, that will mean that those 4 cells are going to take all the resources, and there will be no space for that cell. And blue warrior cells are spawned. They are born if there are 2 or 3 cells where red isn't one of them, and at least one blue is one of them. So it means that that blue is parent of that cell and has, for example, their genes, and same goes for red ones. And the way the dark blue behave, they just spawn anywhere on the map that isn't a cell. So is there something to explain? Or as we see, we can see that normal cells are getting eaten by the blue cells, and after some time there will be no normal cells, and blue and red are competing for.
Rather good. I think you can explain it rather well in this way. So when you talk about anything, the first idea is to say the start. So you have to explain why you have create this model, then talk a little about this model, then show the results, and then tell us the conclusion. So you show us the result. That's great. So we can see that some biological objects are eating another biological object. Okay. And now we have to, I think it's time to explain why we have created this model. Okay, who wants to explain this part? I wanted enough from Daniel, maybe Marco. Can you continue?
Explain what exactly? Sorry.
Okay, explain why we
Why do we
create
need
this model.
or
Yes. Very simple question, why?
okay, so I mean we can describe we can describe something, I mean, like spreading of the virus or something like that. I mean,
Okay, you can show your screen and you can show us maybe something. It's very
I don't have
useful.
progress on this, I mean, on the game of life, so I don't know what to show you.
Just show me code and explain. Why are you doing it?
Sorry, can you repeat? I don't understand.
One more time.
Also, why is he doing what?
Why am I doing what? I haven't done anything about game of life or anything like.
Okay. Okay. Okay.
We use it to simulate what's going on in real life.
Great.
Additional question. Why what? I missed it also. Sorry.
Very simple. No, okay. Very simple question. Why are you? Why did you do this model? The first time.
Would answer like, yeah, Nina, you wanted to say something?
Yeah, maybe I can try and
Yeah.
answer the question. Okay, so from my point of view, the main concept of why machine learning is such a useful tool is the fact that it gives us the opportunity to actually simulate and see how a certain situation is going to play out, given a certain set of rules, without having actually to test it in real life. And that is exactly what we have done here. We have modeled the spreading and the life of given cells with the given rules of how they each interact and span, and we are able to see as time goes by how they are going to act and how each cell kind is going to develop and when they are going to disappear.
Great, really great. So it's a very good idea how you can explain why you're creating these pictures and okay. So first of all, if you want to talk about your work, first of all, you need to tell maybe just several sentences about why it is very important to create your job. Why it is very useful for humanity, maybe, why you create this job. So, Nina, you were great. Okay, the next step is the next step is to describe your model. What is going on in your model? So we saw the results. Let's go to the beginning of this model. So the beginning was something like we have several types of objects. I have heard it. That's great. But then we have to talk about our model. What is going on this screen? So Daniel told that we have different situation when one cell can eat another cell, when the new cell can be burned, and so on. But now you can explain for a while some of this, a lot of these functions. What is going on?
So we separate the execution into frames. On each frame, I explained what is frame. It's a
Okay.
part of time, and we apply the rules that the cells behave in. So first of all, we spawn blue and red, dark blue and red cells. They spawn in a way where there is no other cells. So we have a function here.
Okay. Can I add one question? Maybe it can be again very complex, but can you show an example from real life where this model can be used? So you talk that we have different parts of cells. That's great. But for example, professor told on his phone for half of your presentation, and now or maybe he was sleeping, and now he is wake up, and he wants to understand what is going on. So if he saw a lot of blue and red cells, it was very hard for him to understand again. So it's a good idea to compare with real life.
That let's say, for example, that blue are the good cells and red ones are outliers, and the black ones are like, let's say, neutral cells. They can either help one or another, and so
okay.
Blue and red are in contact, they will just cancel out each other. And
okay, so we talk about cells in an organism, for example.
yes, yes.
Or okay.
So do you want me to go back to the code or talk about rivaling instead?
Okay. I'm sorry for interrupting, but sometimes you can be interrupted by jury, sometimes no. And somebody of jury can ask you a very stupid question. So it's okay to answer, not to hesitate about anything, because it's your work. You know about this work everything. You're the best expert in your work, so you can explain everything. And if someone asks you about your work, it's a joy. It should be a joy for you because your mother, your father, your relatives don't like to hear about this work now because you worked on it very hard and you want to talk about your work for hours, and now you find a man who really wants to understand it. So every question should be for you as an opportunity to talk about your work. So don't hesitate at all. If you want, even if you talk something wrong, maybe I think nobody noticed it and can notice anything of you told wrong. So everything's okay.
Okay.
I'm sorry for interrupting, but my question is great. Okay, my question stops you at all, and it's awful. So it's just an opportunity to talk about your work. You want to talk. You want to explain everything of your work for anyone, everyone.
Okay. Any other questions?
Continue. So, okay, we are working with real cells in organism, and okay, the first question: why your organism is so strange? He is look like a square, and we have a lot of free place into our organism.
Because
Mhm.
because the cells eat resources, and usually they take more space than their.
So our organism at first, can you show me the frame number one?
Can you repeat?
Can you show me the frame number one? Yeah. So at first we have a rather fat organism, a lot of cells. And at the end of this process, we have very thin organism.
Yes, because the way the cells behave is they eat a lot of other cells, and there will be less cells than the starting ones, and they condense into smaller sections. And
So first of all, you have to talk that each cell is its every biological object is its individual object. That it's not the one organism with a lot of cells. That every cell is an individual organism.
we can interpret it as a colony. So
Great.
we can see there's a invisible section that separates these organisms. And
So, for example, we can talk that it's a bacteria on surface of agar, for example, and one type of bacteria is eating another type of bacteria.
Yes.
Great. It's very complex, but you have to explain every step, and you have have an ability to answer very, very stupid questions. For example, once I was with my student on a rather big conference, and one of professors told one question. He asked something like, "Why did you create this big robot if you can use two students instead of it?" And my students, it was the first conference. They stopped and they couldn't answer anything. So even if somebody asks you very, very stupid question, for example, why you choose red and blue colors, can you answer it?
Yes, blue is my favorite color, and red is my least favorite color.
Okay, but why red is eating blue?
As we can see, blue is eating red. So.
Oh. Okay, that's great.
Just kidding. They are the same, but we can favor the one over the another. So later on in this code, because I didn't do part 2, we can set up a way of spawning the darker blue or red that may behave in a different way if organized.
Okay, so, the next stupid question. Why you why did you choose 100 frames? Why you didn't choose, for example, 1000 frames?
Because it will take over 2 minutes to execute, and I didn't want to.
It's not good answer.
To
Maybe I can.
Okay, yes, of course.
Okay, so our task was to find a good balance between a number of frames that is going to give us a precise simulation of the situation we have here, and a number of frames that isn't too big to the point that it is going to require too much computational power that we unfortunately don't have here. And we have figured out that 100 is a perfect number because it gives us a relatively accurate simulation of the given problem. And we also don't really think that using a larger number for the frame number is going to give us that much better results.
Great. That's great. You told the great answer. Okay. Let's talk about anything else. Give me some time. Okay, can you scroll up? And up, and up. Okay. Can you predict what can be if we change such parameters as size of our area? So if we change big N params,
it will
change, for example, we change 50 to 100, for example.
It will take a minute to execute.
No, of course, it will take a lot of time, but
we will get more precise animation on a bigger scale. So more cells are fighting each other, more normal cells are on the board, and everything is just scaled up.
But can be there any okay. So if I will increase this number more and more and more, can I see something, some important differences between small area and big area? If I compare small and big areas, can I see principal differences between them? Or it will work the same whatever size I will take.
So if we have a bigger scale, it will mean that we see. Give me a second.
Okay. Let's try the hard question.
Go for it. If we use a bigger scale, we won't see much of a difference, only some repeating going on. But if we use extremely low parameter like 10, we won't have any how do we say?
Everything will
Everything will not make sense because there isn't a space for them to take or.
No, why? We can see how we can. Okay, at this model we can observe almost real populations. So if we have a small population, everything will be almost the same in the whole area. So if you can see at this small area, you can see that all normal cells will be eaten in several frames. I think everyone was be eaten in 5 or 7 frames. But if we talk about 100 on 100 area, we can see ordinary cells even at the frame number 100. So we can predict, we can compare this behavior of different areas with behavior of big population of animals, for example. So if we talk about bacteria, we can create different kinds of bacteria if we have a big population. If we talk about maybe animals like rabbits or maybe foxes, we can notice that if we have a rather big population, this population will be divided into several subpopulations. So look now at these frames. Everything is the same of this picture. We see something very randomly. Something is appear and disappear, and the average is the same, almost the same. But if we change this area into 100 times, so 100 on 100, can you change? Yes, and start. So we can remember that, for example, in our past, we have a very, very big continent, and we have a rather big populations of different animals. And then, for example, Australia goes far away from other continents, and at Australia, for example, we have the very specific populations of very specific animals. So we can see here, we can see even on frame number 60, 70, and even now we can see normal cells. Even now we can see. So can you stop on at the end of this video? So as we remember, at the small area, everything was finished for black cells in five frames. Now we can see that subpopulations of black cells can survive for ages, for 10 frames, for 100 frames. And now you can see several subpopulations of red and blue cells. For example, we can see a very good blue subpopulation at the bottom of our screen. And we can see that red and black can live together at the right part of our screen. And very strange red population on the left part of our screen. So this area is enough big to create some subpopulations of our cells. As in real life, we can see different colonies on surface of agar. It's hard to explain, but you can see these differences between big and small areas. So if we create this area more bigger, for example, 150 or 200, let's check. No, 150.
Yes.
Yeah, something like this. You can see more interesting things. So this game is very useful, really, to emulate real life. Okay,
We're
it's
just waiting for the
for new video, and I think the new video will be very interesting. No, I'm sure in it.
my video.
No. We are waiting a new video while the new video will be
A
created.
new video. Oh, I
New
see.
video, of course. Yeah, and I am sure that we can see a lot of interesting things on new video because we increase our area in several times, in 4 times. So it will take.
And the number of steps, the number of iterations, was it changed?
No, the number of iterations is the same, but the area of the field is much bigger. So it will take.
So more calculations are going on, and it takes more than 8 times.
So you can see that you can change the whole picture in. Oh, yeah, great. To say the truth, if we will see at real microbiological objects, this picture is closer to real life. So if you change this number of this area, for example, in 10 times, of course, you can, after our lesson, you can change it and, for example, go to drink a cup of coffee or to have a dinner. And then you can see a very interesting film about this the life of these cells. So you can see that if we have another big area, a lot of ordinary cells is alive. So if we create a rather big area, we can create an opportunity for our black cells to be alive for the whole time. So we can see oh, I'm sorry. Alexei wrote me something. Okay. So the answer on this, I think, quite a stupid question. If we change the area, we can answer that the picture will be changed very much. Okay. So the next idea, okay, if we change the number of frames, can we change something in the same way? For example, if we change, okay, now I understand that if I change number of frames from 100 to 10,000, I think this picture will be almost the same, because we can see that the evolution is going on, but the main part is in the past. Okay, I advise you to game to play with this opportunities to change different elements. For example, if we change the beginning conditions, if we increase the number of black cells or if we increase another cells, we can change our solution. And now go back. Let's go to the last frame. And can you yeah, and just stop it. Okay, can you explain what we can see on this picture?
So on this picture, we can see that the blue cells are getting grouped up,
Right.
and red, and there is a big space between them, and not a lot of black cells survived, but some of them did, and they just stay there because there's a big gap between all the cells around.
Great. So the main idea I wanted to tell you that if you increase this field and increase the number of frames, for example, in 10 times, and you can see the end of evolution of this system. So I think you can see several isolation subpopulations, and then it can be rather stable. And if you can create a more, as Alexei told, you can create a graphic of time and number of cells of different types. And you can create this graphic and see the evolution of this system. I think you can see several very interesting graphics. For example, I think you can see not just ordinary lines or just only exponent. I think you can see something like sinus or cosinus.
Do you want me to create it now?
I think it will take a lot of time, so I advise all of you to check it today at the evening or maybe tomorrow. It's very interesting. You can, for example, start it at the evening and increase the number of all parameters very high, and you can see at the morning the result of your calculations. It really can be very interesting, and it's can relate with real behavior of bacteria, of animals. And to say the truth, we can predict the behavior of people with the same model. So, for example, you can ask for a little. You can ask Alexei for a little about how people, about behavior people in internet. It's you can describe them the same ways as you describe the cells, these bacterial cells. Okay, it's not about our lesson, but I told it. Okay, let's do something with our work. And now the question, the last update, as I remember, is to create variables. So, can you explain how the behavior of this population can be changed by these variables?
Can you
Okay.
repeat very?
Okay. Can you scroll up? As I remember, several lessons ago, we talked about this model without blue warriors and red warriors.
Yes.
So, can you explain? Okay. Can you tell us what changed when we create blue warriors and red warriors?
We just label and different, and in the rules we apply slightly different rules. So are you asking for warriors specifically or for all cells?
Whatever you want. So I means, to say the truth, I means that you will talk about the pictures. But of course, you can, if you're not sure about pictures, you can. Okay, one more idea. If you understand that the question is very stupid, or you couldn't answer this question, or maybe you think that this question has a trick or something else. So in this case, you can formally answer this question in the good way, as you did. Tell about. Can you scroll up? You can start with something like, yeah, it's a good question. So we have to change a lot of our mathematical equations. We change our mathematical way of calculating, and now you have time to explain everything you want. So it's a simple trick. Somebody asks you a very strange or very stupid, as you think, question, and if you start to answer this question, you can maybe you can stop or you can be confused and so on. So you can just formally answer several questions about math, and then you have an opportunity to talk something very interesting from your point of view, several sentences about your work. So, for example, you can start with the question, and then you can go to the part of your work which is very, very familiar to you, which is to the part you can proud for, which is your masterpiece. So, for example, you answer that, yes, we have to change a lot of our math, a lot of our equations, and now you can add something from your style. Can you add something very interesting from your work?
So this isn't very interesting, in my opinion.
No, it's awful, of course. It's very, very interesting for you. It's a masterpiece of your life. Even you don't another way, you need to talk in this way.
Okay.
Yes, I know you can lie for a while, for a little, but if you talk to jury that, oh, your questions was so stupid and I'm so clever that I don't want to talk with you, it's what's awful. So every time you need to talk that, oh, you have very good question. For example, if you don't know what to say, you can say, it's a very good question. I have never thought about it. Take me a minute to think about it. And if you worked in company, for example, you can wait for 1 minute with such stupid phrases like, oh, wait a minute, I need the time to think. And for example, at this time, Nina or Marco can think. And for example, you can stop and they can continue your sentence with something like, oh, look, this part of your question was great. So we have to change some math, show some a lot of math, a lot of code, and then said something. And now we want to add whatever you want. To say the truth, to add something that you are sure in, and to show the best sides of your work. Is it clear?
Absolutely.
Let's try. So, for example, I ask you a very stupid question. You add red and blue variables. So, can you explain me what changed in your work at this time?
Very good question. When we added the blue and the red cells, we added some new calculations. We can't treat them like the normal cells. We have to calculate something similar in a way for them to be born or to die. And in this code where we apply the rules, we instead of I can boot up the old code if you want, but let me talk about
okay, it's very bored to talk about this math because you can understand that even a professor can be in jury. It was very hard for him to understand a lot of math. So you have to show, you can show this math for maybe 10, 15, maybe 20 seconds. But the main mistake you can do is to explain, if nobody asks you about it, to explain this like the complex equations. So you can show them to show that you are right, the clever man, that you can work with such strange and big math. And then you can finish your talk with a conclusion with very, very simple idea. So very simple idea is to show a picture or to show a very something very, very simple that a man can remember. For example, if I were you, I would say something like, can you scroll down? For example, at your last slide or slides after thank you for your attention, you can add special slides with very interesting pictures. So, for example, in the previous time when we create an area of 100 to 100, we have several subpopulations of our cells. It was very obvious, it was very simple to show these subpopulations. And so you can tell that I add these variables and they make my subpopulations at my area more stable. And now, look, I take an area of 100 to 100 and I can show you a very interesting picture when I can see real several subpopulations of blue and red cells. It was a very simple idea. You can show it, and it's this picture. It was as a conclusion. Everyone, if your work is really good, everyone will remember this picture. So even when you came to the final of this meeting, everyone will should remember only very strong sides of your work. For example, very good pictures or very good graphs and so on. And they should only to remember this picture and this graph. And it's not necessary if they remember strange math and so on. Because it's hard to explain, it's hard to understand so big area of math, of Python, and so on. Pictures is very, very simple way how you can visualization your data. And it's easy to remember. I'm sorry for so long speech, but I think you can. I want to make it very clear for you that you can, even if you don't want, or even if you don't like to talk about something very strange, you can show something. You can create a very good show for people who is sitting in front of you.
Okay, we can change the code a bit so it behaves like there was only normal cells, like in the last example. We can put here some
Okay, yes.
less parameters
Mm-hmm.
and set the time for blue and red special cell leaving to 0, and I think there won't be any blue or red spells.
Great.
But I'm not sure. Yes, because we kill them after they spawn, they actually spawn. So it's not.
Yeah, can be born again. That's okay.
But
Yeah, that's great. So I want to tell you that if we were on a real meeting, on a real conference. Yes, thank you. It's a good idea to you have some hours to create this system, and it's a good idea to copy, to save some pictures, and then you can show how you can transfer, how you can the evolution of your system. You can show evolution of the population, and you can show evolution of the system. Of course, now you can show how the life is working, how bacteria can live if they have only ordinary cells. Then you can add red cells and see how they eat our ordinary cells, or then add another type of cells, and you can show the difference between these models. That the system is creating more complex, more interesting, and you can talk about this more complex area, this more complex system, more and more and more. So I think you can see that it's a rather simple model, and you can see that you can see almost nothing on your screen. Is it clear?
Yes. But
so yeah.
Okay.
Okay.
Go on.
No. Say what you want.
So we can add the red cells again. Actually, we have to add them both because they are linked to each other. I could load up the other example, but I don't see the tab from the Zoom call.
No, it's not necessary. The main. Okay, I want to. I think it's time to finish, and I want to say only one idea that it's a good thing if you. Okay. I will try to say in this way. If you are creating when you're creating a new solution of task, you need to have in your brain the idea that you need to create the full answer on this task. The full answer, I means that you can create a full presentation about this solution, that you can explain everything in your solution, that you can, if you write something at your model, you have to explain to everyone what can be changed if you change this number. So if you scroll up for a while, for a little, more. Yeah, here. So you can be ready if someone asks you what will be changed if you change n, k, number of frames, update interval, and so on. Everything you have written here, you have to explain. Is it clear?
Yes.
It's a very easy idea, but sometimes students can forget about it, and they can create very, very good solution. And if they couldn't explain in very good and expressive way what is going on in this model, they can lose just because they couldn't show good pictures or create or make a good mood for your listeners, for your jury, and so on. Okay, I think it's time to make you free. Am I right? Vladimir, are you here?
Yeah, yes, I'm here. I'm with you. Well, you can you have 10 more minutes if you need them, but if you're finished, then we can finish now if the guys have no questions. I mean, maybe they want to ask something. For instance, maybe they are sad about something. Yes, Lynn, please.
I have a technical question regarding the actual competition. How long will we have to present the solution?
Last year it was about 20 minutes, maybe half an hour.
Okay,
So
perfect.
you'll need it would be good to have a presentation, to have to show your code, to show your some calculations. Um, you'll have a couple of days to prepare all that.
I mean, I think that will be the least of our problems. I looked at the actual schedule, and if I'm not mistaken, there is a day when the due date is for actually sending our solutions and handing them over, and then the next day is when we are going to present the solution. So we technically have a full day to actually prepare the presentation. So I don't think that will present any sort of a problem.
All night, you mean? uh, I,
Exactly.
I received a detailed schedule like today or maybe yesterday, I suppose today, and I'll send it to you in 10 minutes or so.
Perfect. Thank you.
Okay. So, any other questions? Maybe some requests, some. Okay, well,
I just wanted to ask, are these meetings going to continue happening on Tuesdays? Because I know we were talking about moving these over to the weekend, so maybe like Sunday or something. I mean, personally, that would be uh, better for me, but if the others do not agree and it's not good with their schedule, that's fine. I'm fine with them being on Tuesdays. I would just maybe slightly prefer them being on maybe like Sundays or something.
the schedule of these meetings is completely now up to 4.5 people. The 4 people are the 3 of you and Alexei, who's been teaching most of the part, and 1/2. Well, Andrei has 1/2 vote because he's sometimes helping, like today. So we have this group in Telegram. I suggest that you raise this question there. If you want to shift the meeting to some other day, or maybe you don't want the meeting to be shifted at any time. So, what was the idea? Who said whoever said that the meeting will be on weekends? Was it Alexei? Was it me?
I think it was the meeting when we were talking in Serbian when you told after the second selection problem, Alexei couldn't attend that meeting, and we just lightly
Oh,
mentioned the
I
topic.
might have said I might have said that that now that we have a team,
Yeah,
that meetings can be arranged and scheduled. I mean, uh, we don't need to have like a general and fixed schedule. We can agree on some time that suits everyone, and then have a meeting on that time. So the main message was that now we can move the meeting. I'm not sure that there is. I'm not sure that there are many time slots when both when all can meet. But we can surely discuss this in the Telegram group, because the only reason for that is Alexei is there and he is not here with us now. Actually, he's a bit sick, so I hope that he'll get better soon, and then we can discuss some other time if you want these meetings to be some other time.
Okay, perfect.
Okay, it's a deal then.
Great.
Yeah.
So I think everything is okay.
Yes, I hope that you're not disappointed that
but
you
I
have one half of a voice.
but I think that it's a good idea to create a meeting in maybe in holidays, because we can
By holidays, you mean weekend or some certain holidays?
okay, we can create offline meeting before May, before the conference.
Offline would be interesting. Yes.
Because in this case, no, so as I'm in Serbia, we can meeting together without Alexei. We can connect Alexei by Zoom, for example, and we can create a presentation, and we can to do something with it, because the presentation is the most part of your solution. So you can create a very good solution, but without a very good presentation, it can be very awful. So I think offline meeting can be very useful to check how you can create a real presentation, and how you can work and how you can work together, how you can help to each other to answer any questions. For example, it's not forbidden if, for example, Daniel start to answer and then Nina continue this answer. So you have to work together to find the way how you can change roles, how you can move microphone from one people to another. So I think it's a good idea to create maybe maybe even two offline meetings together and work with presentations.
Yeah, let's discuss the time. I mean, I know that it's not so easy for you to get to the center of the city.
No, for example, I think maybe Monday or maybe Friday at the evening, I can be free. And
Okay,
so
we still need the guy
we can talk about
will be
in
available
Telegram.
also. I mean, because they finish their classes at about, I don't know, maximum 1400 hours, not later. So they need to be somewhere at one place. They all live in different places of the town. I mean, I know it's a small town compared to, like, I don't know, Moscow or New York, but still.
It will take me only 1 hour to get from my home to school, so it's not too far away.
Let's discuss this in Telegram. I don't think that we should waste our time now, because we need Alexei's opinion also.
Okay.
Okay, deal then. Fine, guys. Thank you all. If there are no more questions for now, you know where to find us. And, well, wait, I might turn my camera on for the final word. That's it. Thank you, and we'll stay in touch. Bye-bye.
Thanks you. Goodbye.
Goodbye.
Mm.